Good morning, and today we're going to be looking at the gradient of perpendicular lines. Now, first of all, we have to remember what the word perpendicular means. If we have two lines that are perpendicular, it simply means that they are at right angles to each other. If two lines with gradient, we'll call the first one M1, and gradient M2 are perpendicular, then the connection between those two is simply this, that the gradient of one times the gradient of the other is equal to -1. Conversely, if the gradient of one times the gradient of the other is equal to -1, then we know that the lines with gradients are perpendicular, so we could use that to prove they're perpendicular. To write the perpendicular gradient, if you're given one gradient and you're asked to write the perpendicular gradient, then there is a very simple method that you're going to do. You very simply turn the fraction of the original gradient upside down and you change the sign. So you could be using this fact here to prove that two lines are perpendicular, or you could be asked, given one gradient, what would be the perpendicular gradient to that? This is the method you would use for that. So if you're told one gradient is a certain value and you're asked for the other gradient of the perpendicular line, then you simply turn the fraction upside down and change the sign. I'll show you how to do that in a moment. Okay, so we have point A and B here. Find the gradient of not just AB, but the line perpendicular to AB. Okay, so this is a new higher concept now. So we have to first of all find the gradient of AB using our normal gradient formula. So we have 6 minus -4 over -3 minus 2. Watch out for the double negative in the middle there. I'll give you a wee second to think what the answer to these are. So 6 plus 4 will be a 10 in the top. And -3 minus 2 will be -3 going down a further 2, remember? -5 in the bottom. Okay. 10 divided by 5 is simply 2. A positive divided by a negative is a negative. So the answer is -2. Now you might look at that number and say, that's not a fraction, so how can I turn it upside down and make it the opposite sign? Well, I can make it the opposite sign. It's a negative and it's going to become a positive for the perpendicular gradient. But that's a whole number too, it's not a fraction. So remember this simple trick. If you have a whole number and you want to think of it as a fraction, it is very simply that whole number over 1. So the whole number 2 is very simply a fraction 2 over 1. So remember that, because that will help you to be able to find this in a perpendicular gradient. So the gradient that's perpendicular to this is going to go from a negative to a positive. So you change the sign and it's going to go from 2 over 1 to 1 over 2. Simple, very, very simple. So even if you do have whole numbers that you're dealing with, you can think of them as the whole number over 1 and then turn it upside down. If you have a fraction, say 3/4, you would turn it upside down to be 4/3. Change the sign from a positive to a negative. That would be simple. But the whole number is easy to do as well. So you'll see here that we've changed 2 over 1, an invisible 1, 2 over 1 to 1 over 2, and the negative has changed to a positive. Okay, and that's because of that rule. So remember, turn the fraction upside down and change the sign. Could not be simpler. Okay, so here we have another question. We have a triangle EF and G with the coordinates EF and G given. So we're asked to show that the triangle is right angled at F. Now, whether you have a diagram or not, when you're doing a question like this, you must be able to visualize what you're doing. You must have a diagram in front of you. So I'm just going to draw a random right angled triangle with the letter F at the right angle so I can visualize my triangle. So here I have here. So I've just drawn a triangle. I haven't tried to draw it to scale. I haven't got the coordinates marked in the right positions or anything like that. I've just drawn a right angled triangle. And if I'm trying to show it's marked F, I want to be able to visualize it. So obviously we're going to be using perpendicular gradients to prove that it is right angled at F. Now, because I've drawn this triangle here, I can see that this line here and this line here are to be right angled to each other, perpendicular to each other. I can see, for example, because I have got my triangle drawn, the EG, the line EG, is really irrelevant to this proof that we're going to be making. So if I work out the gradient of EF and find the gradient of that, and work out the gradient of FG and work out the gradient of that, then if it is right angled, I should be able to prove that by saying that the gradient of one times the gradient of the other is equal to -1. That's how you prove it's right angled. Okay, so let's start with E and F. So that's why it's so important to have the diagram, because otherwise people might be working out the gradient of EG, and that's irrelevant to whether this is right angled at F or not. Okay, so let's find the gradient of EF. 7 minus 3 over 5 minus 2, so we've got 4/3. Okay, now let's find the gradient of FG. Okay, so we've got 4 minus 7 over 9 minus 5, which is -3/4. Now, I can see here, oh, right, okay, I can see they are right angled, because this one turned upside down with the sign changed becomes -3/4. But you can't describe it in that way and say, yes, I've turned it upside down, I've changed the sign. You've got to go back to the original proof, which was that gradient 1 times gradient 2 equals -1. That's why you turn it upside down and change the sign. So we go back to that. Okay, so what I've just done here, just very quickly to explain this, I have just changed that to an overall -3/4. We don't want to keep a negative attached to either the top or the bottom of a fraction. We want to show that we know a negative divided by positive is -3/4. So the proof is, or the explanation is, that since the gradient of EF times the gradient of FG is equal to -1, that times that would be equal to -1. EF is perpendicular to FG, and the triangle is right angled at F. So we're going back to the original question to use the wording of the question, show the triangle is right angled at F. So we finished with that sentence at the end there. But we have to know that that means that we're working out that gradients have to be perpendicular, and we're using this little connection here to prove that. And we can see here those two numbers multiplied together would be -1. Okay, right, so we're now on to exercise 1D today. And we have a selection of questions as given. And as always, message your teachers if you need any help, and send in a photo of your marked work so we can give you some advice and support. Okay, good luck and take care.